In this video today, I will be demonstrating the calibration and the operation of Model 3001 Insta Trans O2 transmitter, which also incorporates a sample handling system. The sample handling system may either be constructed for use in a sample that's pressurized or maybe a vacuum type service or very, very low pressure. As it is in this case, we have a couple of inductors in our sample system that will aid in pulling the sample from your sample point into the analyzer to the sensor so that it can be detected. The InstaTrans transmitter is a loop-powered device which provides a 4 to 20 milliamp DC signal. This signal is proportional to the amount of oxygen that is present at the sensor. This 4 to 20 milliamp DC signal is proportional to the amount of oxygen that is at the sensor at any given time. If there is no oxygen at the sensor, your analyzer will be reading 0 and your output will be 4 milliamp DC. If you're reading 25% oxygen, that would be the full scale range, and that would be 20 milliamps. If you're at mid-scale, you can expect to see 12 milliamp DC output. This sample system is designed to pull a sample that is not pressurized and bring it into the analyzer. The sample is not under pressure. We are required to provide some element of pulling the sample through the analyzer. And for this reason, we have installed this inductor system. The sample enters the sample system through this valve here. This is B4. And then it passes through the guard filter. This is a 90 micron filter. Then it goes through the cooling coil, and then to the coalescent filter. The coalescent filter drains through this valve into the yellow input of the inductor E2. The sample continues through the coalescent filter and then goes through a pure film scrubber to remove acid gases before the sample gets to the sensor. Once it passes through the scrubber, it proceeds to a three-way valve. This three-way valve selects between span and sample gases, depending on what mode you're in at the time. During normal operation, you're in sample mode, so you want to switch the valve around, like so, to allow the sample gas to flow through the analyzer. So in the sample position, the gas from your sample goes through the flow meter. The flow meter should be set at a flow rate about 100 to 150 cc's, and the sample continues through the flow meter and then into the analyzer. Once the sensor passes over the sensor, once the gas sample passes over the sensor, whatever oxygen is being detected at the time is being displayed on the display of the analyzer. The sample continues to the other side of the vents to the other side of the system and goes into this T here, which connects to the drain. I will demonstrate the installation of the oxygen sensor into the transmitter. To open the sensor holder, you want to turn this lever counterclockwise just to loosen the plug that will come out in your hand. Your fingers should be on the bottom to pull the cap off. It's attached, so it's not going anywhere. Okay, what you do is you have the oxygen sensor removed from the bag. In this case, we're using a Class A5 sensor. And make sure the side, the white side, which is the sensing membrane, membrane is facing down, and we sit that on top of this holder here with the two contact rings up, because they need to be mating with two spring-loaded contacts that's inside the unit. Once you have this in your hand like this, you want to just go straight up into the analyzer. There is a little hole on the bottom of this that locks into a pin in the bottom, and you'll feel it. You can turn it until you feel the little hole catches. There you go. Alright, the pin and the hole adjustment, and go ahead and turn the ring the opposite direction, which is now clockwise, and close the cell holder. Now the sensor is installed, and you just want to give it to a few minutes or so, maybe about 20 minutes if you're just installing a new sensor, for the sensor to become stabilized before you can start doing a calibration of this unit. Now that we have the oxygen sensor installed, I can go ahead and demonstrate how to do the calibration on the oxygen transmitter. Okay. You have 3 buttons on top and 3 on the bottom, and your display in the middle. You have the range. Actually, there's range switch, the coarse and fine adjust selection, and the run mode, and the up and down arrow. Because we're measuring percent oxygen, you want to see a percent sign on the corner, lower right-hand corner here. If you see a ppm there, you'll know you're not on the right range for percentage. So you want to press the range key until you do see the percent sign come in. So that's important. You want to make sure you're in the percent range. Right now we're in the percent range, and it's saying run because that's the normal operation designation, RUN, saying that yes, it's running. So to start a calibration, you want to go ahead and just press run to make sure you're just to make sure you're in the run position. You press the run key, and that's okay. Now to start calibration, you press the course button. When you do that, you'll see a CRS over your percent sign. So the runs disappeared, and now you're in the course adjustment. You want to do this right away. Once you press the course button, you want to go ahead and adjust your oxygen to read your whatever your span gas is. In this case, I am doing an air calibration, so I'm looking for 20.9% oxygen reading. Okay, so you can go as close as you can, and right now I'm between 20.9 and 21%. And if I need a closer adjustment, I can go ahead and press the fine button, which just allow me to make it just a little bit closer. Like right now we're at 20.9, which is where I want to be for a 20.9 air calibration. If your span gets with something else, you would adjust for that. And calibration is complete. Once you've done the coarse, the fine, make your adjustment for the cal value, whatever your span gas is, then your calibration is complete. Let's look at the piping diagram, the flow diagram, so we can see how the sample travels through the system, the sample handling system, and through the analyzer and back out to the exhaust. Okay, the sample comes in through valve V4, through a guard filter. It's a 90 micron filter, then through a cooling coil to a coalescent filter. The coalescent filter drains through V5 and goes to the yellow input of the inductor 2. The sample that is not drained, just the water drains or the condensate drains, but the sample continues to travel through our pure-fill scrubber where the acid gases is being scrubbed out so that the sample can get clean to the analyzer. The clean sample can get to the analyzer. As it goes through the pure-fill scrubber, it goes to a three-way valve, V3. V3 selects between sample and span gas. If you're in sample, the gas will be flowing straight this way. During calibration, we'll switch the valve this way to let the span gas in. Once they have passed the valve V3, they would both continue the same path. So let's continue with the sample flow. The sample is going through the scrubber, through the three-way valve, and to the flow meter. This flow meter should be set somewhere between 100 and 150 cc's. And I'll explain why in a little bit. The sample continues through the flow meter into the analyzer and passes by the oxygen sensor. At this time, you will notice on the display the percent of oxygen will be displayed here. Whatever amount of oxygen is at the sensor at this time will be displayed here. If you have air coming in, you'll see 20.9% here. The sample gas or span gas now comes through the analyzer and exhausts this way. It goes to this T down to the yellow input of the inductor E1. As a side note, the pure-fill scrubber will have its longest life with lowest flow that is possible. So we want to keep the flow rate at about 100 cc's. The estimated life of the scrubber is 4 months at a flow rate of 100 cc's and an H2S concentration of 500 ppm. The life of the scrubber increases or decreases proportionately to the flow rate or the H2S concentration. So that was the reason we want to keep our flow at a minimum. Between the nitrogen or natural gas input and the vacuum regulator, there's a T which branches off in two different directions. Both directions leading to a valve, a V1 and a valve V2. The valve V1 leads to the red input of inductor E1, while the line from the valve V2 leads to the red input of inductor E2. Both inductors exit to a common exhaust. So the sample comes into the analyzer, being pulled in by the inductor system, flows through to the analyzer, and back out to the inductor and vents to the exhaust. And this concludes our demonstration on the Insta with the sample handling system. Thank you very much.